Welcome, everybody. My name is Jerry Chan, and today we're going to talk about how to build your FROBOT as part of our Building FROBOTs 101 class. So, firstly, we're going to assume that you know a little bit about FROBOTs, the game. FROBOTs is a game where you are taking part in a competitive coding competition, and you try to build FROBOTs that can defeat your opponent's FROBOTs in a virtual arena. In this virtual arena, it's a two-dimensional space, and you are effectively writing this FROBOT, which is an algorithm. It's a strategy that is going to operate a virtual tank, and the goal of the game is to just defeat all your enemies. So in this first installment video, we're going to talk about just the basics of how to get your FROBOT moving in a simple way, like how to just get it to drive the tank. So first off, writing FROBOTs is writing effectively a function in Lua. Lua language is very commonly used for embedded programming. It's very simple. It has a very easy to learn syntax, so it's not really challenging. And it's really ideal for people who are just getting started and learning about computer science. It also supports multi-paradigm, so it's not really strictly functional or object-oriented, so you don't really have to worry about all that computer science theory. You really can just read it, and it's very obvious what the code is trying to do. So FROBOTs, the FROBOTs that you write in Lua interact with the game through a virtual machine, a VM, which is run on the server. So everything that we do with FROBOTs it's basically run in its own little computer of its own. So quickly on the steps of building a FROBOT. The first thing you need to know is that FROBOTs are just a function. It's just an anonymous function where you define what your behavior of FROBOT you want to be. Now, it's also important to mention something called finite state machines. In computer science, a finite state machine is basically an algorithm which has set defined states. That's why it's the finite part of the finite state machine. And you also define the rules or the conditions or the events that would transition your algorithm from one state to the next. Now, this form of programming is very widely used in control systems, things like elevator control systems, robotic control systems, because it's very easy to rationalize what the system is doing just by identifying what state it's in. Now, as we go on with the FROBOTs example, you'll see that programming your FROBOT as a finite state machine actually does make it very, very simple for you to rationalize what it's doing as well. Secondly, when we go into the nitty-gritty of the code, you'll see that when you're writing FROBOTs, you have to be mindful of the fact that you can't write loops the way you would normally write them in computer science. Now, for somebody who's just getting started in FROBOTs, this is probably not an issue. In fact, it's very intuitive. You start off this way. But if you are coming from a computer science background, it might take a little bit of mind shaping in order for you to get out of that mindset where you can write your own loops. Now, the reason for this is, of course, as we mentioned before, the FROBOT is executed within a virtual machine, and that virtual machine is the thing that actually executes, gives your FROBOT cycles, to execution cycles. So you don't really control that, and so therefore you can't really just sort of take over the entire processor and do whatever you like with it. You end up writing the program in a way which is very easy to be time shared and parallelized across computational resources. And of course, this is the holy grail. In fact, for those who are in computer science and you do know or have heard of all of the horror stories of writing multi-threaded code, or the fact that we can't scale CPUs anymore vertically, we have to scale horizontally and try to do things more and more in a parallel fashion. This is the kind of programming paradigm that you want to get used to. So programming FROBOTs hopefully will make you a better programmer. And if you don't know how to program yet and you haven't done it before, then programming a FROBOT will hopefully get you into the mindset of thinking in programming in a way which is very easily will benefit parallel computation. So let's enough talk. Let's jump into some code. And so to do so, once again, if you need instructions on how to install FROBOTs, it's going to be in the link FROBOTs101. From there, you'll get the GitHub where you can download the client, and you can basically start editing your FROBOTs code as what we'll be doing now in our local editor. We're going to use VS Code because that's the common one, and it's supported widely. Now we'll start with a piece of FROBOT code called template. And what we'll do is first we'll get our FROBOT to try to drive in a straight line. Okay, so let's flip over to our code here. Now you'll see that I have a FROBOT template. I've named it optimusprime.lua. It doesn't matter. Whatever you name your FROBOT, it ends up being the name of the FROBOT. But you'll find that if you download the project from GitHub or clone it from GitHub, you'll start with a template.lua in the directory. You can start from that template. It'll look very much like this. Now, the function you see, the only thing you have in this template is a little bit of comments, which is useful. We'll go over these shortly. And really just the function. So as I mentioned, FROBOTs are just a simple anonymous function. So really, this is already a working FROBOT. Now, working is a subjective term. It doesn't do much. So if we were to run the game, the simulation right now, it's just going to sit there. In fact, we'll just do so just to illustrate that. So this is a FROBOT that doesn't do anything. So why don't we just run it and show that? Now what we'll do is we will do something like we'll set a state here. And as you can see up in the comments, there's a special variable state.status where you can set it to whatever string you like, and that's really just how you define your current state. So let's call our current state do nothing, because that's what we're doing. And so with that, we can jump over to our application. We'll just upload our FROBOTs here. That's just so that the server gets our changes. And then we'll pick Optimus Prime and we'll click Fight, which is really just start the simulator. And there is another FROBOT here, a random one. Let's just change it so it's not distracting. We'll change it to a dummy target and then Fight. And so there you can see our FROBOT is this little flashing green and blue one here, the trapezoidal shaped one, and it's doing nothing as we kind of expected. And so it's not very interesting. Now, while we're here, though, let's just quickly go over the little bit of the status indicators in the top. You'll see there's a DM. DM is the amount of damage you've taken. When you hit 100, you're dead. SP is the speed, the current speed you're moving, which is 0. HD is your heading, which is the direction you're moving. SC is the direction you're scanning, which we'll discuss in later tutorials. ST would be your current state, and debug is your current sort of debug text. So let's cancel out of this, and let's see if we can get our FROBOTs to do something more interesting. So before we go into the code, it's going to be useful for us to discuss a little bit about how the arena coordinate system works. Now, if you remember from high school, the coordinate system, Cartesian coordinate system goes something like this. You have the x-axis and you have the y-axis here, and this degree right here we'll call theta. This would be, say, it looks like I've drawn something like 30 degrees, and therefore this going straight up would be 90 degrees. And going this way, let's use a different color to be a little bit better. Going this way would be 180 degrees, and this would be 270 degrees. And that's what you would normally remember from good old math class. Now, unfortunately, because of the way the libraries in computer science, the libraries that FROBOTs use are set up, it turns out that display libraries do use a slightly different coordinate system. So they don't use this, unfortunately. So what they end up using is actually they have a system where the coordinates actually, this is thankfully still x and this is y, but this is actually 45 degrees or 30 or whatever. I drew it close enough to 45 that I think I'll call that 45. And this is actually 90 degrees. And due west would still be 180, but due north is 270. Okay? And this is obviously 0 or 360 degrees. You can use either one. It means the same thing. So we just have to keep in mind that coordinate systems start at 0, the same, but they go clockwise. They don't go counterclockwise. Now, the other thing that's unique, well, not unique to FROBOTs, but the other thing that you should be mindful of is that the XY coordinates are also not what you would normally expect. Now, normally you would say that if you had a coordinate system here, the origin would be 0, 0. And then, say, this point would be 1, 1. And then this point would be -1, 1. And then this point would be -1, -1. And this point would be 1, -1. Right? If we were talking about XYs. Right? Sorry if this is triggering a lot of like traumatic memories from math class for some of you. But I promise this is the only math you'll ever need to know. And this is not really math. This is just the only orientation, sort of algebra, calculus stuff that you need to know. To call this calculus would be an insult, actually. But so that's actually not the way the coordinate system works in FROBOTs. In FROBOTs, because it does use a display library, the origin, 0, 0, is actually the upper left-hand corner. So the upper left-hand corner looks like this. And then if we draw the whole grid, the game grid, I'm using 1,000 because the game grid is 1 kilometer by 1 kilometer. And so 1,000 meters, because we're in a metric system in the future anyway, over where we are. And so 0, 0 is the upper left. 1,000, 1,000 is the lower right. And therefore, you can imagine that here, the upper right would be x 1,000, y 0. And then here would be y 1,000, x 0. Now, why is it done this way? Well, it's probably, I mean, when you're arranging things on a screen, it turns out this is a much easier way to represent things. It also avoids the use of negative numbers, which is good because it's one less thing to get confused about when you're doing math of like translating things around the screen. So it turns out that actually a lot of display libraries use this sort of coordinate system, which has only positive numbers and the upper left-hand corner is 0, 0. So keeping that in mind, let's jump back to our code. So jumping back to our code, we see that we have a little bit of a shortcut notes here. The things that we can actually, the functions that we can call from our FROBOT code, which would drive the tank. And so our first exercise is the drive, so we're going to be using this one primarily, right? But I'll quickly go over them just so that you know. As we scan is something we'll cover later, which is how you sort of use your radar to detect other tanks. Cannon is shooting the cannon, so that's your engaging your weapon. Drive is obviously to drive. Now you notice that these ones all take the first argument as a degree, and this is why we having just discussed the degree system, you need to pass it some number between 0 and 360. In the case of drive, you also need to pass it a speed. The speed is a number between 0 and 100, representing the throttle. So 100 would be the fastest the tank could possibly go, and 0 is stop. Damage is just going to return to you the numeric number of how much damage you've taken. As mentioned before, when your damage hits 100, your tank is destroyed and you lose. Speed is the current speed at which your tank is moving. You'll see that that's very useful to know sometimes. And finally, X and Y, or location X and location Y, lock X, lock Y. That will just return you your current X coordinate of your position and your current Y coordinate. And we'll see how we use that later as well. But let's get started. So in order to drive our FROBOT in a straight line, let's just do something very simple, like just call drive. So if we call drive, and where do we want to go? We want to drive, let's say north. We want to drive straight up. So do we remember which direction, which number should we enter? Well, if you remember from our coordinate system here, straight up is, oh, well, it was the other diagram, but straight up is 270. Because this is 0, this is 90, this is 180 degrees. So 270 is the straight up. So let's take a look at how that's actually affected our FROBOT. We can see that we've chosen Optimus Prime. We've uploaded it. Now let's fight. And there we go. We can see Optimus is dutifully moving north in straight up as we expected he should. Now, so great, that works. But, there's a problem. Like, we've only told him to go straight up, and he's going to continually doing that until he can't do that anymore. And the point at which he can't do it anymore is when he starts colliding with the arena wall, and he kills himself by doing that. So, which we'll see happen very shortly. We'll see he's moving towards a high speed, and boom, right? He hits the wall, his speed goes to 0, and now he has ceased to do anything. So how can we fix this? So let's go back to our code. So the thing that we need to do is we need to make it so that he is doing something other. We need an event which would stop him from continuously moving in a straight up direction, right? And the way we're going to do that is we're going to start making our FROBOT more into a finite state machine. Okay, so what we're going to do is let's define the null state. So first, let's make sure that the state is defined. So what I'm doing here is I'm just ensuring that if the state variable has not been previously defined, let's just create an empty table. And in Lua, a table is just defined by giving empty curly braces. So now we have a table or a dictionary that we can do whatever we want with. Now, what is the null state? The null state is if the state wasn't set before, it will be nil. Sorry, it'll be nil. Then what do we want to do? Well, and if you haven't been set before, let's just jump straight into the drive north state. And we do that by simply saying, okay, well, if you haven't been set before, let's set yourself to drive north. Okay. Else, if state dot status equals drive north, then actually drive north. End. So there you go. There's our simple state machine. There are our conditions by which we change state. And once we get into the state of drive north, we are driving north, right? So let's additionally, at the end of our function, let's just print out our state so that we have something useful. So we can say state or in fact, let's print something more useful. Let's print out the XY coordinates. So for this, we'll use the string format function in Lua. Oops, wrong syntax there. Our X, our Y, and then the two functions that give us our lock X and lock Y. So if any of you are familiar with C, then this string format function will look very familiar. It's just basically passing in a template of what you want to print out. In this case, the x colon and then the actual x coordinate, y colon and then the actual y coordinate, and that %s is just a placeholder for the two variables which you will get later on, defined by these two parameters, which you pass in as the second and the third argument to the function. So with that, let's see how that fares. So let's go back over to our code, upload our FROBOT again, and fight. Okay, so we have a bug here. You can see what happens. Our FROBOT's not doing anything. Why? Well, let's look at our code. It doesn't seem to be starting up to do anything. Okay, so we're back. I actually had a small bug, I have to admit I was guilty of. In the process, I accidentally removed the last statement here, the return state at the end, which was causing some problems. You absolutely do need to return the state variable back, because if you don't, then nothing that you do in this function will carry over to the next cycle. So if you set your state, but you never to drive in, for instance, the driving north state, but then never return the state variable, then you're kind of stuck. So putting that back in and jumping over to our code, choosing Optimus Prime, uploading it, and now we can see Optimus is dutifully going into the drive north state. We can see the XY location as he moves, and we can see that he is indeed moving north. Excellent. All right, so we are well on our way to making our FROBOT do wild and wonderful things. So in the next session, we're going to get Optimus to do something a little bit more interesting, like change directions. So stay tuned for that, and I'll catch you later.